Microphone is on. Thank you for reminding me to check. I have recorded lectures before where it's just totally mute and random writing, and it stinks. Let's get started. Who would like to read this paragraph for me first?
Sure.
Hadassah, thank you.
Both. Ready? You probably know that the sum of interior angles of any triangle is 180 degrees. If you didn't know that, you do now.
Woohoo!
But an important question to ask yourself is, how do you know that? We know a lot of things because we accept it on authority. We believe that we believe what other people tell us. Things such as the distance from the Earth to the Sun is around. Is that million?
93,020,000 miles.
That's too much. Or
just
that
the right
population
amount.
of the United States is growing by about 1% each year. Other things that are just defined to be so, such as the fact that there are 5,280 feet in a mile. That's just such a bad number. Some things we accept as true based on experience or repeated experiments, such as the sun always rises in the east, or I get grounded every time I stay out after midnight.
No cap.
Awful example. In mathematics, we have more formal ways of deciding if something is true.
Excellent. Thank you for reading.
It's like that line from Meet the Robinsons. Excellent.
Excellent. Okay, we are about to do an experiment, okay? So, everybody, you need to get 2 pieces of paper. Very nice. And you are going to trace one triangle on one of them. And I want that triangle to be like less than a third of that piece of paper. Okay? And I want all y'all to come up with a different triangle. Okay?
I call equilateral.
I got this one right.
Oh, you want to talk about an equilateral triangle? Boom, baby. That one was free-handed when we were doing this assignment in, I think, 2019. I was off by 0.3 degrees, I think.
Jeez.
That's
really funny.
And an equilateral triangle is kind of going to be rough, actually. So
Oh yeah.
that was in March 28th of 2019, freehand equilateral. I measured it, and it was off by like 0.3 degrees, which is,
Pretty bad.
not to toot my own horn, but it was pretty baller. I mean, it was sick. What up, dude? So less than a third. When you get that triangle drawn, you also need 3 different colors. So go ahead and get yourself some different colors. Sam, you've already got colors at your table. Yeah. 3 different colors. And you're going to color each of the vertices a different color. It don't matter. Nope.
My brain just needs a princess in the film. The song Dig a Little Deeper.
I don't know what you're talking about.
It starts with don't matter what you look like.
Alright, vámonos. And once you get those 3 vertices colored in different colors, you are going to cut these triangles out.
Ooh, geysers.
Like sharp geysers.
Wait,
Geysers.
where are the
Alright, vámonos, vámonos.
Amigos.
This too small.
No, that's great.
Okay.
That's too big.
That's like a third.
Well, I mean, maybe by area. Try. Maybe you could keep the same triangle, but maybe just like. Go right here. I want it a bit smaller than that. But you don't even have to erase anything. You can just do this because you're gonna cut it out. Cut it out.
Mr. Ball, is that a good triangle?
Say Mr. Ball.
Mr. Ball.
Mr. Ball. That's a great triangle. Go ahead and cut it out.
Wait,
Okay.
what
What are we coloring?
Oh, the bird.
The vertices, the corners.
Ah.
You're just coloring the corners of the
The
triangles.
extra stuff was wrong.
Cut
What?
it out.
Okay.
What?
Just draw the triangle. Woohoo! We're getting there.
Slowly but surely.
Who's Shirley?
I don't know.
Speaking of Shirley, who's Slowly?
Isn't Shirley home for like Sherlock?
What? Sherlock Holmes.
Cheryl.
Well, what is short for Sherlock? Yeah, it's
Cheryl Meat instead of
Cheryl.
Street.
Yeah, wouldn't it be
Cheryl.
Shirley? Surely Sherlock. Yeah, that makes sense.
That makes it.
Actually, I'm pretty sure that in the BBC TV show Sherlock,
Scissors out there.
I think that they call like this the lady that has a crush on him calls him Cheryl.
Cheryl?
Not me,
Like
because I'm
Earl, but Cheryl?
Yep.
I can't slow down.
Okay. You guys getting these done? You need to. Okay. Let's go. Let's go. Hello.
Wow.
I sure can, Lyle.
That
You
was,
bet. Bye.
that was creepy, Mr. Ball.
Sorry.
Fucking
Mia, we're gonna post this on, and you're going to have to try to follow the directions from the interwebs.
Jason,
Okay.
much better.
Yeah.
Okay.
No.
Much better.
I'll try. Scissors.
No.
I gave them to Jay. I was standing
You
right
weren't
next to
paying
you,
attention.
holding the scissors.
Oh, thanks.
So make sure that you're following
Yeah,
along
what
with
do you
this
want me to
when
put
we're
this
done.
in?
All right.
Wait, I'm not.
So you gotta hang on to it, and your second piece of paper, I will tell you in just a second what you're gonna do.
Yeah, you just gotta
It does not involve glue sticks. I hate glue sticks.
Jason doesn't.
Are these
He
not
likes
supposed to be like
drinking them.
templates?
Nope.
Oh my
Okay.
gosh.
I will show you what they do in a minute.
It's lunky.
Oh.
Actually, you could even just
Yay.
read the next section to figure out what we're doing.
See, Mr. Ball, I'm lazy.
I know. It's okay. You can practice to not be that.
Not me not remembering how to draw like obtuse.
You just pick one and cut it out.
Just
I
make a
literally
triangle.
just drew
That's what
one.
I literally just made a triangle.
I'm
think
trying.
this-
All right, we are moving on, Hadassah.
I'm getting
She
there.
needs scissors.
Okay,
Guys.
mine.
Okay.
Mine.
9.
Danka.
9.
Okay, I'm gonna pretend like I've got just a little triangle right here. Okay, and I'm going to draw my triangle on
Oh, we have to draw
this
it.
thing right here.
It says stick on the side of triangles.
I only want us to do one. So here's my triangle that I'm tracing.
You have
Woo.
to trace the triangle.
Yep.
My triangle's really big.
That's why I told you to make it a little smaller, right?
Can I?
And here's what you're going to do. When you trace this triangle, you're going to color its three sides. Ooh. Wow, look at that maroon. That's nice.
Maroon's a good color.
Me when I saw.
I won't be able to get it back, though, which is not awesome. Wait. Yes, I can. That's what we want. That's what the people want. And,
Color it in the same order you have here.
yep, color it in the exact same order. Ooh. Hadassah, vámonos.
I'm doing my best. I had to
Can I have the scissors, please?
Yes.
Thank you.
Let's go.
Mr. Ball,
What?
the day you walked into the bathroom and I had a bloody nose,
Yep.
I returned to class and I was like, my blood was a pretty color.
Yeah, he made that very clear to me. That
That's
we're
good.
very pretty
Because
colored.
blood is
Wasn't a really bad-
All right, we are going to focus. That's very nice that your blood is pretty. Here's the next thing we're going to do. I want you to pick one of the sides of your triangle. Okay, you color these in.
Hey, William. I have to really referring to a dude named Jeff Delmer.
Please don't use last names on the internet.
Just cut it out.
He's well aware, Mr. Ball.
Okay, once you have traced that and colored those three vertices, which also, so color the vertices on another piece of paper, Hadassah, not on this.
No.
Chloe, no. So once you have traced it, and you colored in those
Question.
vertices.
Since-
Sweet,
yes,
here's
I
what we're
don't
gonna
wanna
do.
Cut it down.
Pick, what?
Can I just do it on this side?
What else is on there? Sure, but just say see backside of paper. Okay, so here's what you're gonna do. We're going to find the midpoint of that side, and the way that we'll do it is taking our triangle's side and folding to where those two vertices touch. And then we're gonna put just a little crease in it. So we're gonna just pick any of the sides, any two midpoints, or any two vertices, put them together. to where they touch, and pinch them between your no. Pinch them between your fingers so that the vertex and vertex are touching.
So the colors connect.
Just like that. But see how so it would be like this. Let's say if it's this,
Oh, that
right?
makes sense.
I would just go like that, and then you're gonna pinch the side so that it crimps it in half.
But doesn't need a full.
You want to just crease it at the edge.
Both
So
edges.
vertex to vertex. Just no, and not quite like that. Let me get a bigger.
Bruh, look at this beauty.
My
The fact that
triangle
mine
is
makes
so hard to do.
Okay,
I'm happy.
How?
great.
Okay.
I think. So if this, let's say, here's my triangle. I wanted to do it bigger so that you can see it better. Vertex to vertex,
Yeah.
like this, and I'm going to pinch those two vertices together. Okay, like that. Once I have them pinched together, then I'm going to crimp that side and just put a little pinch right there so that when I open it back up, there's still a crease in the middle. Ready? I'm going to take this. I'm going to put it together. Not in the middle like that. You've got them in the middle like this. I don't want that. I want the vertex to vertex. Just like that.
You are right.
Like fold it.
Are you alright?
No.
Fold
Look,
paper.
like
On
this.
another point.
Vertex to vertex. Just like that.
Thank you, Mr.
So like
You're
we
welcome.
could've
Now
said
put a little
that-
crimp in it.
That's something.
Put a little.
How did you do it on
Okay, here's what we will do with that crimped side is now we are going to rotate that triangle. Oh, I zoomed. Oh. We are going to rotate that triangle. So here's, oh, wrong pen. Oh, brother. If this is the midpoint right here, I'm going to rotate this entire triangle around that midpoint 180 degrees. Okay?
Wait.
So that now when I retrace the triangle, it looks like this. Okay? And now my triangle it's got a yellow up here.
No, you can rotate the thingy. You just want to use the tool by the ruler.
The yellow up here, the blue is down here now, and that maroon for mine is right there.
So we're retracing it now on the.
You're retracing it right next to it. Right next to it.
You're no.
No reflection, just a rotation.
Yeah, yeah, whatever.
What was the point for the piece then?
Because you rotated it about that point. That was the midpoint.
Doesn't matter which one you use.
Nope.
I'm gonna try it in bold. Just.
Okay, so if I were to do this, that would be like, here's my first original shape. I'm going to go around this, rotate it 100 degrees. There's my second shape. Okay, everybody good? You got that traced? Where are you tracing it? There? Excellent, and the colors, oh, beautiful. Now what you're gonna need to do is take the third, or another side that you have not yet traced about. Pinch that one in half. Also make sure that you get the colors down. Excuse me. And you're gonna do that rotation one more time.
So we need like a parallelogram.
Wait, if I flip it.
Like if we do that, that's a trapezoid.
Very nice. Very nice. So rotate it. Good, 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 good. No. Yeah, that's it.
Yeah.
And now you can color that, color that, color that.
Well, I
It's goofy.
Yeah, maybe do a little bit of that. Okay, so then you're gonna pick like this side right here.
Yeah.
Wait, are you not tracing this? Are you just sketching it?
I mean, it wouldn't fit. I'm not redoing it, so.
That's what this paper is for, dude. That's what I had.
Hey, no, it's scaled
It's
up
so
correctly.
hard.
Also,
to-
don't do that with your calculator. That's not what we're doing here today. Okay, so you did this one, right?
Mhm.
Now I want you to do the same thing around this side. So you're gonna go whoop, like
So it's
that.
just gonna be that there.
Wait, on what side?
Yep.
Okay then, I have to just.
So you're going to rotate it one more time. So you've done it here.
From the new spot.
So these are almost identical. Anyway, do it around this side now.
Okay.
So find the midpoint to that side and rotate it one more time. So I will show you on here what I would say it looks like.
The new triangle is from the,
Yep, the one that we just rotated.
we rotate that one again.
So this one, I'm gonna, doggone it.
Dang.
I'm going to use the midpoint of this side now, and I'm gonna rotate it around 180 degrees there. So now I should have a triangle. Oh my gosh. That looks like this.
So it should be the same triangle again from the first one?
Pretty much, yeah.
You only want us to do it 3 times?
Yeah, please, no more.
Well, you would just be doing it over and over again.
I do be doing it over and over again sometimes.
Well, you can only do it 1 more time.
What?
You can do it an infinite amount of times.
Ah, we'll even talk about that soon and very soon. It's called. Does anyone know what that figure is? If you just keep rotating something around the midpoints.
Nothing's gonna
Spheroid or something?
Maybe 3-dimensionally, but I'm thinking 2 dimensions.
Oh, 2-dimensionally? Yeah, I got no clue. Macrystachrome? No.
It's called a tessellation.
Wait, what? I did it wrong. Wait, no, I didn't.
I think I did it.
You should have something that looks like this. Tayson said this is a trapezoid. Does it look like he's correct?
Mm-hmm.
What is a trapezoid?
That, no, that's
That
what's
is
it
the
called?
Oh, it's a.
That what's that called?
Yeah, as long as you're not reusing midpoints, you can only do it 1 more time. Before you have to
Four
start reusing
sides.
midpoints.
Oh, okay. It has 4, so it's a quadrilateral. What is important about the sides? One set has to be what?
Oh,
Parallel. Yeah, or rather, the way that you would actually say that is parallel. Very nice. Yeah, but that is a trapezoid. Nice, sweet. And if that's true, what does this, mine down here, what is this blue and black line? That's awesome.
It's really funny.
It gets
That's
it's
very-
Amazon didn't even know that you drew a smiling face.
It's like smirking. It's got weird pupils and like different sized eyes. Yeah, very good. Okay, so actually he looks pretty happy. I don't know. She, they,
It's a weird kind of face.
I'm colorful. Okay, anyway, what kind of angle is made by that black and blue line down there at the bottom where the smile is?
180.
Yeah, it's a straight line, right? So it makes 180 degrees. We had just talked about in that paragraph that Hadassah read that triangles, their center, or all of their angles add up to 180 degrees, right?
See their center of gravity?
No. Now I can see that I have all 3 colors, yeah? I have all 3 angles of this triangle that add up to 180. So here is some proof that this works.
You're just gonna hear Daisy go, yeah.
Yeah.
Let's
All right.
Let's see what our faces look like.
So we all had different triangles, correct? Nobody used my triangle, nobody used each other's triangle. We all had various triangles.
So we all just pass triangles
true.
around.
Well, no, but this triangle I used the same one. I did make other triangles,
Okay.
but I only used this one on this sketch, right? So, did all of yours create that straight line?
What's
Hey, Willy boy, look at this.
yeah.
Yeah, all of ours created straight lines, didn't they? Which means what about the like the three vertices of any triangle, do you think?
We'll add up to 180.
Yeah, so we could say that with that, all three triangles, and I want you to write this just off to the side, are all three angles of a triangle will add to what? 179?
180. Mm-hmm.
People are gonna be watching
Wait,
this
what?
and they're gonna be so
Why
confused.
did you put 170?
He crossed it out.
And then put a
Yeah,
mad
but I
frowny face.
accidentally put
He's
170.
not trying to.
Text.
There we go.
I have too many questions.
Okay.
Yes, for all triangles, we think.
No, we think no. It's yes.
And why? Based off of this experiment that we just did, why? We all had different triangles, and what did they do?
They all add up to
They all made 180, which was the straight line, right? They all made a straight line. That's the key there. They all made a straight line, which is 180 degrees. Oh. Oh, that was a different experiment. We just did experiment number 2.
You're kidding.
Which is fine. It's good. It's great. It's great even. But we did experiment number 2. So what I want us to do is we're going to actually do experiment number 1 now.
Yay!
Okay? So what I would like for you to do is each of you cut out 2 more triangles.
Do we keep this one?
Actually, you can use that. That could be our first one. And so don't cut out another triangle yet. I changed my mind. Don't cut it out yet. Oh my gosh. You're
What
so
if-
ready.
What if yours are...
Here's what we're going to do.
Just rip paper?
Cut off tear off, not cut off, tear off the 3 vertices of your triangles. Or, yeah.
You know what's funny? Didn't Jacob say
Yeah,
that we were
I was
supposed
like,
to make
don't we need to
multiple
make several
triangles?
triangles?
Yeah.
No.
I forgot. Okay, and then what you're gonna do is each of these have tear bits, right? Like places that you can tell it's torn, and then they have the nice point of the vertex. I want us to put those vertices together, like this, but then I want us to make the sides all touch. Okay? On a piece of paper. So make all the sides touch.
On a separate piece of paper or on this piece?
That's kind of goofy.
You could actually just put it on your table. Sorry, I misspoke.
I don't.
Someone's gonna be watching this and they're gonna be so
Are
confused.
we putting the corners we just ripped off?
Yep, corners you just ripped off.
My,
Are those the 3 corners you ripped off?
No, that the 4 corners are ripped off.
Why did you rip off 4? How
First
do you
of
get
all-
Why is
corners?
there
First of all, how many corners?
So where are the vertices?
Those are the right-
Okay, put them together. Put the vertices
It
together.
looks so weird.
Like the
N, B,
William is the
C.
only individual I know.
it
And
created
then-
a straight line.
Make all the edges touch now.
Rated
oh
N,
like
B,
that.
C.
Yes,
what you
but
mean.
make no spaces.
No space. Okay.
No space. No space.
No space.
No capes. Very good. Sort of.
Look,
Me.
It is good, but it's a little wonky.
Yeah, I know.
Your points were not.
It is good.
I kind of had a stroke while tearing it, but whatever.
Okay. Ooh. Ah.
It sounds so
Very
good.
nice. What did they make?
A straight
They
line.
make a straight line.
They make a funny looking trapezoid. If they were even, it would be a trapezoid.
That's a big if there, pal. Okay, so yes, if they were even, they might make a trapezoid. Nice. But they're not. What they do make is a straight line. Okay? I want you to do it one more time. Cut out one more triangle.
From what?
A piece of paper, dog.
what if I did?
Okay.
We're not
Okay, one more triangle.
I go
somehow my
sir.
wash isn't
Maybe
sour.
cut it out of this one.
Yeah.
Yay.
Okay.
Does it have to be the same or can it be confused?
No, make it totally different.
W.
Totes different.
Never speak
Hey,
again.
Mr. Ball. I'm smart. I just used the corner of the paper.
Ah, dig.
That's what I'm doing.
Brother, sister, let's go. Paschetti. Spaghetti.
Pass spaghetti.
Yes, Mr. Ball.
Make sure that each vertex only has 1 point. Okay, great. That's money, dude. Okay, we are going to do the same thing and tear off the 3
Do you
vertices.
want us to color them?
I didn't need scissors.
Mm-mm.
No.
You're gonna be able to tell the difference though between the torn vertex and the not torn, though, right? Right?
Right.
Yeah.
Right? Okay, good.
Do we do the same thing?
That is literally
Do the same thing.
exactly what he just said.
I couldn't hear.
Deaf.
Whoa,
Lines.
simmer down. Let's not use descriptors of each other as insults, please.
What?
But why?
That last one's kind of goofy, but
This one's a
whatever.
bit wonk.
What? I keep bumping into my other triangle.
Oh no!
That's as good as it's gonna
bless
get.
I need like tweezers or something.
Oh,
He's so small.
Look at that.
Tweezers.
Well, the 10
real nice.
Sam's like hyper focused. You made it so
Gross.
small.
Wait, are you connecting all of them? Why? Just do the new one. Also, you breathed and it moved them.
Yo, that's like a trapezoid or something.
So you're saying I can't breathe?
No.
Yeah.
What?
Yes, you cannot breathe.
Okay.
You're not allowed to.
What does that make?
Oh no, they're
180.
It makes another straight line, which a straight line has how many degrees?
None.
180.
Because it doesn't bend at all. So
It's okay. A straight line normally is 0.
No, a straight line has 180 degrees. Not 0.
I don't know how
Well, because it doesn't bend at all.
True, but that's a straight line, which is 180 degrees.
With 0.
Measuring from here to here.
Oh, I just saw that it didn't move at all. And was like,
Oh, gotcha. Sure. No, it does move. All right, cool. So we agree then, again, these vertices line up to create straight lines, 180 degrees. Is this true for all triangles now? I would say so. I do suppose so. Very nice. Okay.
So we're done?
No, we did experiment number 2. Okay. Whew. Okay, here's what we are going to do now. We are going to examine said diagram. Okay. Experiment number 2 produced a sequence of triangles as illustrated in the following diagram. Diaphragm.
all the papers off my desk.
No, Mr. Ball.
right.
Diagram.
Boom. 1. Boom. 2. Boom. 3.
Boom.
What do y'all see?
Juice.
I see.
I see a trapezoid, clear as can be.
Very nice. What about here? What'd that make?
That's a
That'd be,
parallelogram.
Oh, yeah. Look at that. It's
Also,
parallelogram.
isn't that other one not a trapezoid because the two sides
Trapezoid.
are parallel?
So
No,
a trapezoid requires only 1 pair of parallel sides.
Okay, it requires one pair of parallel sides and for the other two to not be parallel.
Yeah, so it actually necessitates that there is one and only one pair of parallel
Okay.
sides.
So they can be completely
I don't know why,
different
but I was not thinking that.
You might be thinking of an isosceles trapezoid,
Probably.
where side AB over here and side A prime C double prime are congruent. That's an isosceles trapezoid.
There are even
you
trapezoids where side AB will be at a right angle to BA. Wait a minute.
Hold on. ¿Como eso?
Yeah. Yep.
Ah! Whoa! What on earth?
Whoa.
Oh my goodness. This has gone downhill quickly. So like this?
Uh-huh.
Yeah, it's like if you were to hide this side right here,
See, Sam agrees with me.
it's like it would be a rectangle. But then if you are like, wow, then there's a trapezoid. Okay?
Wow.
Wow.
You want some graphite dust?
No, thank you. So here's some interesting questions that we might ask. The second figure, do you think it will always be a parallelogram? We have one up here, so I want you to examine your figures and tell me, is your figure a parallelogram?
No.
Your second figure.
Yeah.
Yes. So that's the problem.
Well, it has to be
Let's see,
Yeah, it
what
is.
dictates a parallelogram?
two sets of opposite parallel sides.
So if you were to just look at
this, right?
This one right here. Yeah, it looks like it is a parallelogram. Yours almost kind of even looks like a rhombus, what's a rhombus?
Oh,
Parallelogram with equilateral sides.
It's a parallelogram that has like a square property of that all sides are congruent, right? So that could even be a rhombus. Not sure, we'd have to take some measurements. But in a general case, because a rhombus is a parallelogram, so in the general case, all of ours look like parallelograms, yeah? Okay, cool. So we might think the answer should be probably, yeah, it always will be a parallelogram. All of ours, right now, our reason is that all of ours were. Okay, that's our reasoning right now. Later, we're going to formalize our reasoning, but not yet. Now, number 6, will the last figure always be a trapezoid?
Trapezoid, yeah.
Trapezoid.
Yeah.
from our
It looks like it, yeah, from our studies. Again, that Y is, in our experience so far, excuse me, and the powers of our observation have dictated, yes, trapezoid.
Are we done?
And number 7,
There's a number 7?
No.
There don't be number 7.
Stop.
do your homework.
So we have 5.1.
Can we throw away
Yep,
some?
5.1.
Can we throw away the paper?
You can throw away the paper. Actually, yes, recycle, please. Oh, good, we got that on recording. We're recycling. We are green.
Questions.